Hi everyone, and welcome to this State of the Game event hosted on the Nexus Aurora Discord server and live streamed on YouTube channel. I am Ollie, also known as Migeto on Discord, and I am your host. Today I
Hi
am
everyone.
joined and welcome to this State of the Game event hosted on the Nexus. Today I am joined with another Space Nut and Will.
Hello, everyone.
Hello.
Thank you guys for joining me. Yeah, so we're back for another live stream. The last one was a couple months ago, but we hope we can get it right this time and have these more frequently because they're very fun. And me doing this event again is also part of a broader effort to increase our involvement in the Nexus Aurora YouTube channel. More content will be published there soon, so keep an eye out for that. That being said, let's start with our first piece of news, which is the Artemis program. There's a couple things we want to cover up on the Artemis program. I will link it. Just give me a second.
I think it's quite interesting that people are quite eager for Artemis 1 when officially Artemis 1 launched last week with Capstone, didn't it?
Yeah. So I don't know why. Do you guys see my screen? Um, okay,
No.
we're starting with a technical issue, it seems.
Stream delay.
Oh yeah, maybe it's the delay. Okay, so let me know if you can see my screen, but it doesn't seem to show up on OBS.
You're gonna have to change your screen share settings.
Okay.
Sorry, everyone.
So I think the interesting thing about Capstone is that it was the size of just a microwave, and they've future-proofed the technology, haven't they?
Yeah, we're on the agreement for the Artemis Corporation, but I'll get the Windows capture fixed in a moment. Okay. Okay, it should be good now. All right, so let's start with it. So, a memorandum of understanding was signed between NASA and ESA regarding the Lunar Pathfinder mission. ESA's Lunar Pathfinder mission has the objective of advancing the communications infrastructure needed at the Moon for a long-term human presence. NASA, on the other hand, is planning the delivery of the mission to lunar orbit via the commercial Lunar Payload Services delivery. So in the article that I shared with you, I don't know if there was a date that was announced. I don't think so.
Wednesday. The states as Wednesday. It was released on the 15th of June.
Yeah, but I don't know when it will be launched. I think it's yeah. The agreement was signed on Wednesday.
Wednesday, the 15th of June, that
Mm-hmm.
agreement was signed.
Yeah, uh, but it doesn't say it's nope, no date for the. All right, but this is quite interesting. I mean, it's part of the Artemis program, and cooperation between NASA and ESA uh, is always good to see for the Artemis program. Do you guys think more agreements like that are to come?
I mean, I think the Artemis Accords that were initially signed for the Artemis Agreement basically solidified international partnership, in my opinion. You know, you've got things like the Halo module for the Lunar Gateway being developed in Europe and other strategic parts of the Artemis mission. So I think it's a good thing. You can achieve more when you cooperate more.
Yeah, yeah, of course. Um, so this is going well. I mean, NASA has signed multiple agreements at the beginning of the year and last year for the Artemis Accords. Many countries hopped in the accord from all around the world. I remember South Korea joined, um, and many others. Many small countries that doesn't necessarily have space capabilities, space launch capabilities at least, but they could have some technology involvement, or they could even be mentored sort of by NASA to develop their own capabilities. So this will be interesting to see in the next few months and years.
And I think that's the thing to remember there. Things on this scale usually get actioned over years, don't they? Although we've seen some Accords partners sign that we don't necessarily assume are going to be a spacefaring nation. You know, things are going to be changing in 5, 10 years when those Accords are relevant.
Yeah, yeah, of course, of course. All right, and on to our next subject. Still part of the Artemis program is here. We have the. Oops, sorry. Seems like the link didn't work. Still getting the hang of it, guys. I'm getting there. Okay. Um, what's going on with this one? Thanks, Will.
No problem.
All right. So capstone. So on June 28th, a Rocket Lab Electron rocket lifted off carrying the cislunar autonomous positioning system technology operations and navigation experiment, which is dubbed Capstone. The spacecraft is said to be a pathfinder for Gateway, which is a moon orbiting outpost that is part of the NASA's Artemis program. And in the linked article, there's a few objectives that is that says so verify the characteristics of a cislunar near rectilinear halo orbit for future spacecraft, demonstrate entering and maintaining this unique orbit that provides a highly efficient path to the moon's surface and back. And there's a couple more. Gain experience with small dedicated launches of CubeSats beyond low Earth orbit to the moon and beyond the moon orbit. So this is a very interesting experiment, and you were saying something about it, another space nut, right?
Yeah, I mean, I'm quite a fan of what Rocket Labs have launched here. Like, well, obviously, first of all, I'm another space nut. You know, like I'm obsessed with anything to do with space, and Capstone really, for me, starts like we've been talking on social media for 2 years about how we're going back and how the new moon missions are a thing, and really Capstone is the first and probably one of the most pivotal pieces of the Artemis program. You know, it's future proof, so the communications that they're running on board Capstone are a new type of communication, which is going to be efficient and continue a presence on the moon over the coming years. Really, overall, a capstone. It's a founding piece of what the Artemis missions are hoping to achieve, in my opinion.
Mm-hmm. Yeah, yeah. Yeah, I think it's very crucial to the Artemis mission, and it's just a little CubeSat. It's like 55 pounds, um, and it's really meant to test the unique orbit that a gateway will have. Yeah, so yeah, it's really interesting. What do you think about it, Will?
Well, I'm excited because this is like the first step in for NASA and all the other countries that have signed the Artemis Accords. So
Yeah, yeah, obviously. I mean, I can't wait to see Gateway. There was a lot of controversy, I recall, around Gateway, whether it was needed or not. But it seems like with Capstone, they're really uh, going forward with this, and they've been meaning to go forward with the Gateway for a while now. Um, but I don't know. I'm skeptic for the use Gateway will have beyond the Artemis mission. Do you guys think Gateway will have some use beyond the Artemis mission?
I mean, me
it could
personally,
probably have some use for launching missions to Mars from the moon. I'm not exactly sure what, but probably would have some use.
I think they've just included the gateway because it was in the original plans. Past that, they don't. I mean, the whole Artemis thing. To be fair, is we just want to go back to the moon. It was simply the legacy of the previous administration to return a man to the moon.
And a
I
woman.
think, yeah, and first woman,
Yeah,
which
first woman.
he's going to be amazing. It shows that diversity has hit even as far as the moon. I think Gateway will provide use through Artemis. Um, I, once again, I think we're going to be opening up low Earth orbit to a lot of commercial opportunities. So it might see a second wind as part of a commercial venture once the Artemis program's over and done with. Or at least I'd like to think so. So it's not a complete waste of money.
Yeah, yeah, that's a good point. I think that if the gateway is to be used for missions to Mars, it will be it will need to be adapted for it. Like new models will need to be installed, and so on. And I'm not sure that it will be built with that in mind.
Mhm.
It will have to be seen.
I think, to be fair, after speaking with companies like Orbital Assembly Corporation about their station and how modular and future proof that station is, it really makes me think a lot about how NASA could save a lot of money just going elsewhere for a station. If I'm being completely honest, it feels like they could put that money at a better use, but are choosing not to.
Yeah, I'm on your side with this. I also think that. All right, and on to our next piece of news is lately there was the Wedger's rehearsal that happened for SLS. Um, okay, I'm still not posting the links in
If you
the
just copy it directly from the doc, it
yeah
just posts the text. You have to right click copy link.
yeah, I get it. Okay, I'll do it manually then, like this. All right. So yeah, NASA completed the Wedger's rehearsal, and it's moving towards launch, but there's still a couple of things that need to be fixed with SLS. And part of that is a valve, I think, a seal. Sorry. So I'll post another link where you can find information about that famous seal. And basically, SLS rocket and Orion spacecraft went back to the vehicle assembly line to replace a seal on the quick disconnect of the tail service. And this was an issue that was linked to a liquid hydrogen leak. So it's not a, I don't see this as a small thing. There's obviously a lot of um, repair, I think, maybe to do, and testing to do for SLS to be ready for launch. And there's still no news about if SLS will launch by the end of the year or the beginning of next year. We can take bets, obviously. I mean, bets are open. Do you guys think it will launch by the end of the year or next year? Or even in maybe in 2024?
I'd like to think it'd launch this year. I mean, we've been.
Mm-hmm.
It was originally scheduled to go, what, 2018?
Yeah, something like that. Yeah.
Now, 4 years later, we've finally got hardware, which I'm really hyped about. But it seems like, I mean, I'm not necessarily a SpaceX fanboy. I like what SpaceX are doing. But if you compare the speed of, a private company in comparison to an entire space administration service, it kind of puts it into perspective that cost plus systems are still very much dominating the industry, in my opinion.
Yeah. Yeah, totally. I mean the SLS rocket has faced a lot of setback. There was news about how they face setback because of problem with hardware, because of problems with management. Um, I mean, basically they face every issue that could be possible. So if they manage to launch the rocket, whenever they manage to launch the rocket, it will be, I think, really a good show of resilience. How Boeing still managed to do that beyond everything they faced, and it's still the only rocket. I mean, Orion spacecraft is, I think, the only um, spacecraft that is rated for human spaceflight beyond Earth orbit. There's no other spacecraft that is rated for that. Um, of course, there's work for Starship uh, to be ready for that, but it's
Mm-hmm.
far from being done.
I mean, if you look at how long it took SpaceX to get a human rated as a company, their first rocket along their timeline was, what, 18 years, 17 years
Yeah,
to human rate their first piece of hardware. I think a lot of people are counting their chickens and putting a lot of faith in Elon Musk's SpaceX. To be fair, there's a lot of bureaucracy in the way, and I see quite common on social media people saying, "Oh, scrap the SLS. Starship Lab was there by the end of the year." I mean, it took 17 years to get Dragon Crew rated. Starship's not taking Artemis astronauts to the moon. Well,
yeah,
not anytime soon, at least. I'm not saying it won't, but it's not going to be this year, next year that Starship's online. I think the SLS has more of a chance.
yeah. Obviously, and it's easy to see with that that is that SLS and Orion are NASA's best bet to return to the moon as soon as possible.
Starship has to be able to land astronauts on the moon, I think, by the time Artemis 3 rolls around. So Starship has to be crew rated by then. So it should be in the next few years, unless everything gets delayed, which it usually does, but still.
Yeah. And thank you, by the way, Vincent, for joining in. I didn't introduce you. It's my bad. So thank you for
No
joining in.
problem.
Yeah.
Yep, I just kind of hopped in.
It's fine. All right.
Welcome.
Yeah, welcome to the show.
Um,
And so Vincent, when do you think SLS will launch?
I think if it's not this year, it's definitely next year. But I don't have high hopes for this year, so I think it's a 50-50 chance between the end of this year or next year.
Okay, yeah. Yeah, seems about right. I think basically everybody gives them very little chance to launch SLS by the end of the year, and it seems a lot more probable, considering all the issues Boeing faced, to be during next year.
Which I'd agree. I'd say that definitely should be the takeaway from this. Boeing, under extreme pressure and a lot of negative press over the last couple of years, have still managed to get the Space Launch System somewhat close to ready, not too far behind when it should have been in the grand scheme of things. So credit where it's due to Boeing.
Yeah, yeah, obviously, and a lot of people think that Starship will be able to replace SLS at some point during the Artemis program. But like we said, Starship is not human rated yet for even going to the Earth orbit. I mean, we'll get to Starship later in the event, but it's there's still a lot of work to do before it's human rated, or even before it's ready to get into the Earth's orbit with the booster, obviously.
The question that I ask anybody that says Starship should be replacing the SLS is, would you yourself right now be the test pilot for Starship, even for a hop?
Yeah, would you guys?
Would anyone here want to be the test pilot for a hop of SpaceX's Starship in its current format?
Uh,
It'd be a pass for me.
So
Can
then
we
you
just
wouldn't
get
expect
can we
astronauts
just
to
get
ride on
like
it, right?
yup. Can we just get a clip of all Starship explosions in the last year and a half?
And this is my point. I think the SLS, I think it seems pretty unanimous here that we all agree it's either flying this year or next year. Once it passes that initial certification flight, there's no good reason humans aren't on board. Well, I mean, other than the obvious, it's Boeing and something will go wrong. But other than that, there shouldn't be any good reason. Unlike Starship, that's still got to start. It's even as Ollie was saying, it's not even currently rated to take humans to low Earth orbit, let alone the moon.
Yeah. Yeah, exactly. All right. So I still have another piece of news that is about the Artemis mission. I'll link it in chat. And it's about a possible nuclear power on the moon.
So I've seen this design before. This is the kilo power generator, isn't it?
Yeah, it is. So NASA selected 3 design concept proposals for a fission surface power system design that could be ready to launch by the end of the decade for a demonstration on the moon. Each contract is valued at approximately $5 million and funds the development of initial design concepts for a 40 kilowatt class fission power system to last at least 10 years in the lunar environment. And so there's the 3 companies that were selected were Lockheed Martin, who will partner with JWST and Creer, who I don't know about. The second was Westinghouse, who will partner with Aerojet Rocketdyne, and the third one is IX in Texas. So 3 U.S. companies, and IX of Houston will be doing a joint venture with Intuitive Machines and X Energy and Maxar and Boeing. So this is a big joint venture for that last proposal. So
So I think
yeah.
the interesting thing for me, I remember the same year that I saw Simon from our community talking about disaster avoidance on Mars. they were talking about the kilo power generator for Martian use cases. And I think at the time they said 5 would be enough, and then anything more than that, and Mars would be ready for its first nuclear power station, as opposed to these smaller kilo power generators. But that's quite interesting that, you know, such a small amount of mass can basically achieve everything we'd need. I think it's very good that they brought the concept on board with the Artemis program, and it should do wonderful things for humanity's return to the moon.
Yeah, I agree. Yeah, and this is, I think, part of the program that could be taken and, like you said, used for the exploration of Mars. So this is a very interesting part of the program, I think, and it was about time that they announced it. What about you, Vincent? What do you think this fission power system will allow us to do on the moon?
Yeah, well, I mean, for the moon, like it'd just be like since they're going to the South Pole, which means that well, I mean, actually, I'm pretty sure this applies to everyone on the moon, but you know, like the day and night cycles are super long because you know the moon's tidally locked to the Earth and the orbit's about a month, so I think you would have like what 15 days of shadow about, or maybe more or less, I think, and not only that, since you're looking for ice, you might be in a shadowy corner of a crater, which means that you get almost no sunlight. So nuclear power is gonna be like super helpful unless you want to build a huge solar array. That's like that might be far from your base. You know, it'd be a hassle. And then this will also help with Mars because solar power at Mars is a huge issue because if you want to fuel up a starship, it takes so much solar panels. It's like ridiculous. Like it could be done, but it's like nuclear power would make everything so much easier for the moon and Mars.
Yeah, totally. Um, and I see someone asking in chat, what's the expected cost for SLS and Starship to LTO? I have 1 billion and 15 million in my notes. So I myself don't really know what the expected costs are. I think you're about right, where SLS is 1 billion and Starship is 50 million. But you have to keep in mind that the Starship costs is theoretical because it hasn't been tested out yet, right? So this could be a number taken out of Elon's ass, basically, and it could be true or it could be way more than that or way less. But the 1 billion for SLS seems to check out. I remember we covered that at some point in the past, but I don't recall the exact number.
I think if I'm not mistaken, it's 2.5 billion for the first 5 or 10 launches of the SLS, and then it gets cheaper. So by the time it's done, it averages at $1 billion. But
yeah,
that's providing they stick with the current plan for the Artemis missions. Starship, Elon touted the original number of an internal cost to SpaceX at 2 million to launch the system. But two things there. That's one, the internal cost for SpaceX. They're not just going to launch it and make no profit. And number two, it's Elon Musk maths as well. Like, this is the guy that said starships would be flying towards Mars in 2022.
Yeah.
So,
and that would be 1 million people on Mars by 2050?
Yeah. So
I'm pretty sure someone did the math on that. It's hilarious.
The Starship super heavy numbers I'd definitely take with a pinch of salt. I'd say 50 million, 100 million ish.
Yeah.
A used one.
I mean, honestly, if he manages to do it under 100 million, it'll still be like a huge win for the space industry.
I mean, to put it into perspective, the data analysis works out that across the lifetime of Falcon launches, it's seen a 10-fold reduction in the cost of launch overall. Now, that's just simply, first of all, that's because it's the only reusable rocket that you can say SpaceX created that wave. But the Falcon 9 payload's much smaller than Starship payload. I think it's going to be quite interesting to see once Starship, even if it is just launching Starlink initially, or military contracts have been spoken about, or I know there was initially plans for international aid, disaster relief and things like that using Starship. So you can say, okay, there's been an earthquake in Haiti, deploy life-saving equipment and needed supplies in under an hour using a rocket.
Yeah.
Once we see these kind of use cases from it, it'll dramatically reduce the cost of the system, I think.
Oh yeah, for sure. Yeah. All right, and there's another question in chat. So it's Marcity asking about the international limitations on nuclear power, because at the moment it's impossible to send a nuclear reactor or anything nuclear powered in space beyond what is the little spacecrafts or satellite that are meant for exploration, right? Because nuclear is basically weapons of mass destruction, right? So yeah, there can be a lot of protrusions from the international community, as you point out, and this will be a very interesting negotiation between NASA and the other, well, the other member of the international community who have space capabilities, because Russia is one country, well, I mean, maybe they abandoned the project now, but Russia was one of the countries that wanted to do a nuclear propulsed spacecraft to go to Mars. And they were actually the first ones to suggest that we should send a nuclear reactor to Mars. So this is there may be some consensus that nuclear power is the best option for space exploration, but there of course will need to be negotiations there, where they will have to get a consensus on how that needs to be handled.
I think, see, I know that there's been a lot of talk of putting a lot of carbon into the atmosphere of Mars to try and kickstart an atmosphere. And I think this makes more sense on the moon if you were going for that approach than it would on Mars. You want to make Mars dirty to try and give it an atmosphere.
Yeah, yeah, and oh, it's Simon. Hi, Simon. Thank you for the question. It was a good question. And yeah, and I remember back when we did our the the contest for the design of a city-state on Mars for 1 million people for a Mars society. There was some talk in the Nexus Aurora community about using nuclear bombs to for mining purposes, basically. So the bombs would be detonated on Mars before humans can arrive, and that would be very useful for mining purposes. It would facilitate the process according to that group of people, basically. But like you said, my position on that was that we wouldn't want to um, sully the atmosphere of Mars, even if it's very small or very thin, uh, before the arrival of humans. I think it would be a grave mistake.
I'd say until we can rule out definitively that there's even microscopic life on Mars, we should avoid doing anything catastrophic. We already screwed one planet up fairly well. The last thing we need to do is go and kill ancient life on another planet before we had an opportunity to study it and understand our own building blocks.
Or contaminate it.
Oh, okay.
And then rediscover like amoeba or something.
Yeah, yeah. Imagine if we get on Mars and after we detonated um, a few nuclear bombs there for mining purposes, and we discovered that amoeba and it's irradiated with um, what is it? The cesium, I think. Anyway, and Simon points out that it's not about the use for the regulation of nuclear in space, but it's about the amount of nuclear material. Okay, so well, thanks for that precision.
I mean, with that in mind, Simon, if you were to think about all the radioactive thermal generators currently on Mars, there's quite a lot of nuclear material already decaying there, to be fair. So I think we do have an issue with nuclear on Earth. I think not so much in space, as long as it's, overseen. Like, as a good example, if the Americans decommission a nuclear reactor as part of an agreement with China and Russia, they're to display that in the open so that a satellite can see the reactor. I think as long as there was an open policy of what the use for the nuclear material on surface would be, I think there'd be less obstacles.
Yeah, I think you're right. I think part of the agreement needs to be based on how the how the nuclear object basically can be monitored by the other nations while it's in space, and how these other nations can develop prevention means for for any types of weapon that could be developed on that. Okay. Well, all right.
Guys, I'm going to say thank you for having me on the show today, but I'm going to have to duck out. But thank you for tuning in, everybody that's here, and thank you for having me, guys.
Hey, thank you, Another Space Nut, for coming in. It's really appreciated to have you here, and you can come
Thanks
back
for dropping
anytime.
by.
Yeah.
Take care.
Bye. See you.
Yeah.
All right. So let's keep going with moon exploration. So this is not part of the Artemis program, but it's still part of moon exploration, and it's Lone Star, which is a startup that wants to put a data center on the moon. And so the argument for that is that important data can be stored on the moon and left untouched for as long as can be in case of a cataclysmic event on Earth. And 3 months ago, Lone Star signed contracts to launch prototype demonstrations of its software and hardware capabilities aboard 2 lunar landers with NASA-funded aerospace business innovative machines. So it seems like it's going well for them, and seems like they will be able to show what their capabilities are, and I think it's one of the first project to be going to the moon that will have a use beyond the exploration or the simple occupation of the moon. And I think they want to put these data center in lava tubes. Yeah, this is what the title says at least. So they will need to find lava tubes that are proper for that purpose. Because going into the lava tubes, we need to explore them first, and then we need to determine whether or not they are suitable for that use. And when I mean suitable, what I mean is, um, are there are they prone to um, oh, I don't have that word in English. Um, I don't know. It's to crushing the data center.
Single
Um,
event upsets.
Pardon me.
Well, I think the specific thing you're talking about is single event upsets (SCUs), where
Yeah,
basically a stray particle from space just like flips a bit in the storage,
yeah.
and
Also,
the memory or the processor can sometimes fix that depending on how good it is. But if a ton of it happens at once, it just crashes.
yeah, that's right. Because I
And
don't
it could
think.
also decay the storage over time.
Yeah,
if you
exactly.
flip enough bits.
Yeah, because we don't know whether or not putting these data storage in lava tubes will be enough to protect them from outer space radiation. This is a good
It might
point.
just, you probably would just have a lot of redundancy and a lava tube and whatever they can.
Yeah, yeah, but there will. My opinion is they will need to solidify a lava tube if they want to put data center in there. And there's no telling that there's any lava tubes that are big enough to have a data center. And there's also the issue of power. I mean, if they power it with nuclear power, then fine. But if they use solar arrays, then it might be problematic to bring that power into the lava tubes or to ensure that it's always lit up. Maybe a combination of both would be best. But yeah, that still needs to be done, and it will take many years before I think we can see a lava tube on not a lava tube, but a data center in Moon's lava tubes.
Another problem is that, well, if it's a problem getting power into the lava tube, it's also going to be power getting, like, internet into the lava tube. Like, well, there is plans to bring a cellular, like, 4G network to Mars, which is kind of cool, but they would have to have a receiver on top of the lava tube and then bring that signal down. Or I guess it could be fully wireless, but I don't know how far, if 4G could travel through solid rock.
Yeah, yeah, that's a very good point. So yeah, a lot of challenges Lone Star will have to face before they can have their data centers on the moons.
So like, how like who's gonna want to buy their services? Because like it's not gonna be cheap, and I don't think it'll have any obvious advantages over Earth-based systems, other than like in case the world ends, your data is safe. Like that doesn't seem like a very sound economical plan to me. But I don't know. I mean, maybe I'm missing something.
I mean, I guess it could be like the ultimate backup for companies, like for like major companies,
Yeah, I
because
guess.
it's like on Earth, your backup center, like, and any number of things can happen. Like the worst case scenario on Earth is that, well, like the data center gets destroyed, but on the moon, it's hard to do that. It's hard for a competitor or whatever to like go to the moon and just blow up your data center or whatever.
Yeah, it's true, I guess. But
Yeah, and
I don't know. We'll see.
maybe
Ultimate
it will
security,
be
basically.
harder. Maybe it will be harder to hack. Maybe it will. I think it will mainly serve as an archiving system, right?
Mm-hmm.
Well, where you can
It,
store the like most of the archive of the humanity, our history and things like that. Something like the plant storage in where is it? It's in Iceland, I think.
there's
Or
also like the GitHub vault where they store a bunch of
yeah,
open source projects in the Arctic.
yeah, that's the one.
There's the seed vault and the code vault.
Yeah, the Doomsday Vault, I think what it's called.
There's a few of them. There's the one for code, one for plant seeds.
Yeah, so there's already kind of some of them on Earth that see uses, but seeing one of the moon will be like the ultimate vault is on the moon.
Mm-hmm.
Yeah, but for sure it will be very costly to do.
And it's a 1 second uplink downlink time, like 1 light second away.
Yeah,
So it'd be slow.
yeah, that's right.
Well, it wouldn't be. I guess it didn't have to be slow, but the latency would be bad
Yeah, that's right.
because you
Um,
could still transmit data quickly, but the latency. So
yeah. Imagine if they have issue with the internet, you'll have to bring the data with you on a space flight. That would be so bad.
you have an issue with the internet, you have to like send an engineer up.
Yeah, one of the engineers has to hop on a rocket and push a button on one of the servers in the lava tubes.
Yep. Because the thing is, if there's a problem with the internet, we basically can't communicate. Well, I guess we could just go back to using like radio to get everything set up. But what if the radio also goes down?
Yeah. Well, can you tell me what the last comment of Simon is, because it's on a white background and I'm having a hard time reading it.
Simon said, "Do you consider also a computation capacity for AI on the moon?" And then he said, "AI with 1 second delay would be your."
Okay. Yeah, I think we've addressed that, didn't we?
Well, he's asking about artificial intelligence
Oh,
specifically.
artificial intelligence. Okay, so how artificial intelligence would be linked with the data center? Um, Honestly, I don't know. I don't know. Maybe if we can develop an artificial intelligence to take care of the data center, but that's way beyond our capabilities at this point.
Yeah, like what would you need an AI for if you're doing an archive on the moon?
Yeah, yeah, because I guess um, that an archive on the moon would need a human presence if you don't have an AI maintaining it, and that could be an issue, right?
Yeah,
Well, it
I
doesn't
guess that's
necessarily need a human presence. You could just send someone up if something went wrong, which is not. We're not very capable of that right now, but this data center is years away, and maybe then we can just go to the moon whenever we need to.
Yeah, maybe.
But it's a stretch.
Yeah.
All of
also
this is a little bit of a stretch.
you could probably have like some sort of humanoid robot like in the center for anything like physically need to do. Because the delay is 1 second, so it's not actually like impossible to control a robot. And especially if you have someone in lunar orbit that can do that, um, like you could probably just maintain the server with robots controlled by humans.
Mm-hmm. Because from the lunar orbit, it's a few milliseconds delay, not anything crazy.
Yeah, exactly.
Okay. Well, I hope that answers your question. All right. So our next topic. So we're going away from the moon and to orbit, and we have the OSAM 1 mission. That is, so it's NASA's planning a mission to demonstrate the ability to repair and upgrade satellites in Earth orbit, and a mission called OSAM-1 for on-orbit servicing, assembly, and manufacturing 1. So I guess if there's a 1, that means there will be other missions for that. Um, and it will send a robotic spacecraft equipped with robotic arms and all the tools and equipment needed to fix, refuel, or extend satellites' lifespans, even if those satellites were not designed to be serviced on orbit. The first test flight of OSM-1 is scheduled for launch no earlier than 2026 and will conduct a first of its kind refueling demonstration test, then relocate the satellite to a new orbit. So
But could it repair Hubble? Like, remember a few years ago, or I
yeah,
forget how long ago it was, when they had to send, when NASA had to send astronauts up in a space shuttle to go fix Hubble because of the mirror being ever so slightly bent out of shape. Would that be able to do this? Would be able to take out the mirror and replace it? Because that's been our main repair problem.
yeah, that's a really good question. I don't have the answer to that. Do you have an idea, Vincent?
I mean, I doubt that like the silo will have the like I guess like the dexterity of humans there. So it might be possible. You know, might be possible, but it might just take like a lot longer because we have to um check basically everything with ground control before you do it. As humans can kind of work on the fly, even though obviously you're still checking stuff with ground control. But like, having humans is like having like really advanced humanoid AI robots,
Yep.
like doing that. So versus like the satellite, which probably, I mean, it probably has some AI systems on it, but nothing like serious. I mean, actually, I don't know much about the satellites, so I might be wrong, but like, um, I think the satellite will probably only be able to do like basic repairs, and I think orbital boosts probably too. Um, but yeah, I think humans will be better for repairing. And I don't know if the
Mhm.
satellite could repair Hubble, but I mean, we'll see because it might have to because Hubble's starting to degrade.
Yep. It's
Yeah,
crazy though, because the problem with Hubble at the originally was like I think it was bent out of shape by like a few millimeters, like ever so slightly, like not noticeable to the human eye. Then we had to go send up humans with a new mirror to fix it, which is kind of crazy.
yeah, totally it is. Yeah, so maybe Hubble could be part of that program at some point. Another I'm thinking about is Starship. So we know that Starship will need to be refueled, not only to go to the moon, but also to go to Mars at some point. And working on that technology and on that capability um, for 2026, I think is really good. It's really good.
Okay, I checked, and the Hubble flaw was not a few millimeters. It was actually 1/50th the width of a human hair,
Jesus.
and they had to go fix it with the human because it was impacting the image quality a noticeable amount.
Yep, but
Vincent?
sorry, yeah. So I had the script open, so when I did push talk, I started typing in the script. So
It's fine.
what I was gonna say is, it might be useful for something like JWST, where like we can't really get humans there now. Or actually, I mean, we like hypothetically, if we had to, we can probably get humans there with humans to Hubble with Dragon, but like if we had to, but we can't do that with something like with the James Webb Space Telescope. So this might actually be helpful for something like that.
Yeah, that's a good point. But this is on orbit servicing. They don't specify. Oh, they say Earth orbit, so it's not ready for JWST yet. I think,
Maybe for
um,
OSIM too.
yeah, OSM 2 or maybe OSM 5. We never know about these things.
Yeah, but I mean, this technology could probably be expanded to like the bronze points, or maybe even like I mean, I know there are some telescopes that I think are they in like solar orbit, like in a near Earth orbit. I think uh, I might be misremembering here, but I think Spitzer was one of the telescopes like that, right? Where it was, I think it wasn't in Earth's sphere of influence. Let me check. I might be wrong.
All right, but like we said, this mission will be very interesting. It's a really great news for the Artemis program and for a possible journey to Mars. And now that we're on Mars, oh, there's a couple questions. Could you read them out? I'm still having the same issue. Well, I think my screen on OBS is way too small to allow me to read those.
Sure. So let me see. Uh, Someone in chat is saying, somewhat related, Lockheed Martin is proposing a mission augmentation port map standard for standard docking to satellites on orbit. And then he says, they publish specs, and I'm working on publishing open source CAD with a mech engineer friend.
Oh, that's great. That's really
Yeah, that's
great.
really cool.
Yeah, yeah. Do you have
And
a
then
do you have a link you can post to us so we can look at it maybe? Otherwise, it's fine. We have enough content for the stream anyway. All right, and you
and
were
then
saying?
someone said, "What you can fix, you can also break."
Yeah, that's true.
So let's hope OSAM doesn't actually break some very expensive satellites.
Yeah, of course. Um, would you imagine they start doing repairs on Hubble and they just break it beyond repair while
Accidentally
servicing it?
scraped the mirror by like 1/10 of a human hair
Yeah, 1/10 of a human hair is enough.
instead of 1/50th.
Yeah. All right. So we'll go to our next segment, which is Mars exploration. And the first article I'm gonna link to you guys is about looking for evidence of life. So basically, NASA suggests that we need to dig deeper than we have done for evidence of life on Mars. And rovers may have to dig about 2 meters or more under the Martian surface to find signs of ancient life because ionizing radiation from space degrades small molecules, such as amino acids, relatively quickly. So my question is this, and I'm happy we have Vincent with us in this discussion. Um, so my question is this to you, Vincent. Is this possible for a rover to dig about 2 meters on the Martian surface? Or do you think it requires a human presence?
It would be it probably would be possible if you had a rover like specifically designed to dig like 2 meters deep. It'd be a pretty big rover. Like I know Viper, um I think was supposed to go to the moon. I'm pretty sure that has like a pretty big drill on it. And we actually that's where I got inspiration partially from for the drill on the Sam rover. Um so that worked on Explora. So I think it would be possible, but it will be easier with humans. You need probably less complicated technology. Like humans could use like a handheld. Well, I mean humans theoretically could use like shovels on Mars, but you probably want something a little more advanced. But whatever humans could use, it'd probably be a lot simpler than robots. But um, getting humans in the first place is also difficult. So it's kind of a trade off. I think robots could do it though. It would just be it'd be pretty difficult, but it shouldn't be impossible.
Would it be like a drill that detaches from a rover that has like a few things on it that can just drill down?
Yeah,
Trying
I
to think
mean maybe.
what's the word for it? Well, almost like what we're planning on doing with Europa, except instead like on Europa we'd be planning to melt through the ice with a kind of like a drill shaped thing, but for Mars we just do it with a normal drill. I don't know if that would work.
I know on NASA's like Insight mission, I think they had that like drill. I think that was like on a cord to measure like the temperature of the ground or the lower
Yeah,
soil on Mars,
it's the
which actually
InSight
failed.
mission. Yeah.
Yeah, the drill actually I think it got stuck like a few inches into the ground. But if you had something like that, I think it'd be pretty compact and it might be possible to reach deeper into the ground. It also depends on like like the makeup. Like the stone could be too hard. Like we need to know these things beforehand probably. Like the um like how tough the ground is to actually drill. That'd be a big factor too.
Yeah, I think one of the issue they faced with Insight was that the ground was like you said, the ground was not as expected, and it wasn't dense enough for the drill to go deeper. So they had to use their little shovel that they had on the rover to press against the drill so it could go deep enough. But
So we'd
even
probably have to send another rover before then to go measure to go like sample a bunch of different places, dirt and stone.
That sounds like a mission for Sam. Sam.
Yes,
yeah, yeah, just send your
that would be
proposal to
very cool.
NASA. Yeah,
Yeah.
yeah, that would be amazing.
For those watching the stream who don't know, Vincent's one of our team members. From what
Yep.
I understand, it you're basically the CAD lead, right, Vincent?
Cameron's like head lead. I'm right now it's like me and Cameron working on uh the mechanical side, and we have some software and electrical engineers working on obviously the electronics and softwares too. Um, so yeah, so Cameron's the lead of the SSAM project, Sam, which by the way, SSAM stands for Scout, Sample, and Map. Just for anyone out there who's wondering. So basically, uh, should I give like a brief summary of like the mission profile if you
Yeah,
guys are
sure,
interested?
sure, go ahead.
Yeah. So basically, like we're right now like so the objective of the mission is to um so okay, sorry, let me back up a little bit. The mission is designed for a tech demonstrator for the Mars Society right now. So I think it's back in like beginning of 2021, I believe, when the mission and the project started. Um, the Mars Society basically I guess contracted us. I don't know. They're paying us money to develop this as a tech demonstrator, but basically the objective is to map out a certain area of like land and get terrain data and mineral like data. So this could be useful for community landings on the Mars or Moon if you want to know where you're landing before you actually land there. Um, so basically, I'm planning on using a rover swarm that can take a bunch of samples of the land and analyze them and send the data back to Earth. So right now, it's a tech demonstrator for the Mars Society, but obviously the long term goal is to actually get the space rated. Um, which we'll see. That's a probably a long time for now, but it might happen. So yeah.
Yeah, that is amazing, and I think you guys got a sponsorship for that, right?
Oh yeah, we were sponsored by the sheep cryptocurrency. So uh, if if a rover does make it smart in the future, we'll have some sort of sheep like I don't know, like coin or some sort of decal, and you'd be literally taking sheep to Mars if the rover does make it to Mars, which would be pretty funny. Yeah.
Yeah, that will be pretty amazing. I mean, just sending cryptocurrency to another planet, and leaving it there for anyone to find once we can put human on Mars. Hopefully, it will be worth a little more than it is right now. But I'm sure it's not a problem. It's still time to get on the train, right?
Yeah,
Um,
we'll see. I mean, crypto's always going up and down, so
yeah,
yeah, who knows? Who knows what's gonna happen in the future?
yeah, yeah, of course. But we're really happy with that sponsorship. I think it was really big for that project, and it really helped them out progress in their steps to getting to Mars.
You also have a few other sponsorships, right? But I'm not sure if you're allowed to talk about them.
It's probably more of a question for Cameron, honestly, because he's like the project lead, so he would know all,
Mhm.
about all this stuff. Uh, yeah, but
I
I
know
don't
I
know
know
where
there's
I don't know where
saws, but
Cameron
I
is
don't
right
know.
now.
I know
Oh
there's
yeah, okay.
saws, but I don't know if you're allowed to talk about that.
I don't know. I'm not gonna talk about it just in
Yeah,
case,
okay.
but
Yeah, that's
there,
fine.
there,
Yep.
there- there's some cool stuff though. Yeah.
Yeah, that's cool. And just keep an eye out on our Twitter if you want to see these announced. Um, yeah. Well, thanks for that, Vincent. Um,
No problem.
and we're still on Mars. There's a Perseverance mission. So Perseverance, I think, was launched in 2020, if I recall correctly.
No, yeah.
Yeah. All right. And so, yeah, NASA and ESA are partnering in the Mars Sample Return Program to establish a new group of researchers to maximize the scientific potential Mars rock and sediment samples that would be returned to Earth. And you can find a complete list of members via the linked article. So basically, there is a bunch of researchers that group together to deliberate on how they can experiment on on the samples that will return from Mars. And I think um, a few companies were submitted their proposals to NASA at the beginning of the year to return a sample, but it's not yet certain when that will happen or how that will happen. So they're still working on that. But it's a very complex mission. I think personally, I think JAXA, the Japanese space agency, is the most advanced in sample returns mission because they're doing it for an asteroid. I think they're doing it now twice for an asteroid, and we'll talk about it later during the stream. Um, but yeah, Perseverance basically is doing samples on Mars of rocks, and they want to send it back to the Earth so we can study them. And that might enlighten us on the previous piece of news that I shared with you guys about where and how we have to dig on Mars to find possible signs or evidence of life. So, what do you think, guys, about this mission? Um, I mean, what would be my question rather would be what would be your contribution? How would you like to study these samples that would return from Mars? Vincent?
Uh, well, I think first, I think everyone wants to know about like is there life on Mars, right? So um, obviously, I think the first thing we don't look for is like those like amino acids and stuff that that I mentioned earlier about digging deeper into Mars. We don't want to search for basically any signs of life first, and then we might also like on the that's on the searching for life side. On the other side, we might want to look for like mineral data or some sort of ores that we can find. So we can give us like getting mineral data would help with colonization efforts because we want to know about what resources are there before we go there, so we know how to best take advantage of them. So there's both the discovering life side and the colonization side benefits to um, getting samples back from Mars.
Yeah, I think another way of experimenting with rock and sediment samples from Mars would be to look at how we can make bricks out of Martian regolith, because this is very important to build a city on Mars, right?
Didn't we have a project about that during the Mars Society competition?
I mean, we didn't have a project per se, but it was
It
one
was
of
part of the
yeah, and it was one of our
society.
interests because we wanted to well, we planned to have um, vaults made out of regolith, made out of bricks, made out of regoliths, and these vaults would protect the temporary habitats that are meant for the astronauts on Mars for the first occupants of Mars.
I don't
Um,
know how viable regolith would be because I don't. Well,
Yeah, it's
I don't know
the
how easy it would be to just pressurize that.
yeah, it's the
But
same.
if it was less protection thing, it would probably be fine.
Yeah, yeah, it's meant for to protect from radiations.
Radiation,
Yeah,
yeah.
radiations and solar light basically. Um, but otherwise, I don't think you can pressurize a room inside just a room made out of regolith bricks. Uh, yeah, you
There's some
need
seriously strong glue or something.
yeah yeah we need
Mortar,
mhm.
Mars mortar.
Yeah, Mars mortar. Yeah, exactly. But I know most of the concepts for a Mars habitat, whether it's big or small. Um, when it's at the beginning of the occupation of Mars, it uses Martian regolith. So yeah, that would be a very interesting experiment, I think. What about you, Will? You have anything in mind?
Uh, for the Mars, for making bricks out of the Mars regolith, I mean.
No, no, I mean to study the rock and sediment samples that would be returned to Earth. What use would be made out of those?
I I don't know much about studying rock samples, but I assume there'd be some like spectropsy involved to determine the chemical composition and
Yeah,
whatever else we do to study rocks.
yeah, yeah, yeah. Fair point. Okay.
Probably similar to studying moon rocks
Yeah,
stuck
yeah,
on Earth.
exactly. Okay. And now that we're talking about studying moon rocks, the next piece of article I have for you guys is about the Psyche asteroid. I don't know if you guys know about the Spike asteroid.
Psyche, I
Yeah,
think.
Psyche. Yeah, yeah. I
Yeah.
always pronounce that wrong. I don't know. Yeah, the Psyche. But yeah, basically there was a mission delay for the Psyche mission to a point
It's
where
supposed to be the isn't Psyche supposed to be the most like valuable asteroid or
yeah,
something?
yeah, exactly. Yeah, it's something like value at I don't know, $15 trillion worth of platinum or something like that. Uh,
I think someone else did like an independent study on it, and they determined it could be anywhere from $43 to $15 trillion or something.
yeah, yeah,
So
yeah,
who knows?
exactly. Yeah, it's pretty absurd, but
Maybe this will help us determine it.
yeah, maybe. But the mission is not planned for 2022 anymore. And due to the late delivery of the spacecraft's flight software and testing equipment, NASA does not have enough time to complete the testing ahead of this year's launch period, which ends in October. So the other available launch periods are in 2023 and 2024, with an estimated time of arrival in 2029 and 2030. But originally the spacecraft was set to arrive at the asteroid in 2026. So this is a pretty major setback I think. Um, when considering that the just 1 year or two delay adds in 4 years basically of delay for the spacecraft to arrive at the asteroid. Yeah, so sorry to all those people out there that were psyched about the mission. Yeah, that was pretty bad.
We're all psyched for Psyche.
Yeah, psych for psyche, exactly. Yeah, but yeah, basically, like you said, Will, it's a pretty interesting asteroid that could be valued. Uh, I mean, the materials, if they manage to bring back materials from there, enough materials from there,
And they
it,
could sell it. They'd study it, but it would be pretty valuable.
yeah, it would be pretty valuable. But the
How much
thing
does a
is,
kilogram of titanium cost, anyways?
oh,
Or
I know, I
platinum?
think, yeah, platinum. Yeah, I think it's platinum. But one of the major issue is bringing those back to Earth, right? It would be very costly to send a spacecraft, have that spacecraft mine an amount
25,000 euros
25,000
per
euros
kilogram,
per kilogram. All right.
or
So
$29,000, almost $30,000.
yeah, and
That's insane.
yeah, that's pretty insane. But bringing these back to Earth, I think it would be very difficult um, on a spacecraft that is able to mine. Except if you're able to send a spacecraft, maybe that's the best way. So you're able to send a spacecraft over there that can do the mining job, and you have another spacecraft that can do the transportation job. So you free up space in the transportation spacecraft for more platinum, right? And then you can maybe bring that back on Earth. But you still need enough space and enough weight capability for fuel, which is a major issue.
Well, apparently, Psyche or Psyche, whatever it is,
Yeah, it's like
has been reported to contain 700 quintillion dollars worth of gold, and it says enough
quintillion.
for every, and it says enough for every person on Earth to receive about $93 billion.
Gold.
Yeah, and that's with today's market value. So
Mm-hmm.
when it does,
And
if it
that's from Harvard,
yeah
so it seems fairly reputable.
yeah okay, thanks for that.
That's insane.
Yeah, that is insane.
It would probably crash the world's economy, to be honest.
Yeah,
Like,
absolutely. And
if 700 quintillion dollars worth of gold came into the market, I don't think gold would be. I don't think that gold would be worth 700 quintillion dollars anymore.
gold or platinum?
Yeah, gold.
Gold. Oh, gee.
Yeah, if that much gold entered the market at once, the price would just drop.
Yeah, absolutely. Um, I think one of the best thing I have in mind for Psyche is a concept that Robert Zubrin from the Mars Society suggested, where for the exploration of our solar system, he suggested a triangular trading pattern between Earth, Mars, and the asteroid belt. Something along the lines of what happened during uh, the colonization era of the Americas, which was between Europe, the North America, and Africa. And that could mean that there's a trading system that is viable between three parties. And so what could happen is that there's Earth that sends equipment to Mars. So equipment made out of for computers, for example, is made out of rare materials, right? That you cannot easily mine on Mars. And you send or equipment that requires very specific means of production that you can't basically find, that you can basically have on Mars. So they send that over to Mars. Mars, on the other hand, would have farming capabilities and enough farming capabilities to feed the people that live in the asteroid belt. And so they would trade with people in the asteroid belt with food. Whereas people from the asteroid belt would send rare materials that were required for the Earth to produce the equipment that Mars requires. So that would be very interesting, and I think this is what the future could hold for us. What do you think, guys?
Well, the asteroid belt is a viable place for colonization, theoretically,
Yeah, theoretically.
because what I've seen is you just like hollow it out, and then you rotate it to create centrifugal force.
Okay.
The Expanse. Have you read The
Yeah.
Expanse?
Yeah, the expanse basically. Yeah.
Yeah.
Yeah, that's what it reminded me
Yeah.
of too.
Well, I guess it's just a good concept.
Yeah,
If
yeah.
it's in a book, then it seems scientifically sound, so.
Mhm. Yeah, exactly.
And
Um,
it'd be easier than like building a spaceship 30 kilometers or whatever, like a humongous spacecraft and rotating that. So,
yeah, yeah. Maybe I don't know.
and
Maybe
once you
there's
hollow it out, you get a bunch of valuable resources depending on which asteroid you mine. So it's kind of just a win-win.
yeah. I think one of the issues with mining the asteroid belt, right, is the time that it takes to get there and to get from the asteroid belt back to Earth. Right? Just with the Psyche mission, it's estimated about between 4 and 7 years, 4 and 6 years of transportation with our current means. Obviously, maybe that could be shortened out with better technology, but um, I think that with the current timelines that we have for transport, it's just not viable at the moment. Yeah. All right. Um, so I have other news about the James Webb Space Telescope. So most of you that spoke with me a few times know that I'm very fascinated with the James Webb Space Telescope. And it finally launched recently, and it's ready to take pictures. And there's a countdown of less than 9 days before we receive the first image of the space telescope, of the James Webb Space Telescope. And if I recall correctly, that first image will be an image from the universe, and it's the furthest that we've ever seen before. So this will be very, very exciting.
What's it imaging?
Pardon me?
Like, what is it imaging?
Oh, it's like I said, it's imaging the furthest that we've ever seen in the universe. Like
Is it imaging a specific object
no, no,
or?
no, I don't think so. I think it's just imaging. It's just taking a broad picture of the universe, the closest to the Big Bang.
So just as
Yeah.
zoomed in as possible on one specific part of the sky,
Yeah, I guess so.
like Hubble Deep Field,
Yeah,
but even like more zoomed in. Okay.
yeah. But I think people at NASA have already received that image, and they're analyzing it. It's just not ready to be published yet.
Probably.
Yeah,
Data analysis takes a while for images,
yeah.
especially something as huge as this.
So what do you think, you guys? What do you think we will see in that image?
Galaxies.
Galaxies, a bunch of galaxies.
I mean, have you seen Hubble Deep Field?
Yeah, yeah. I have, of course.
Well, that's just a ton of galaxies, and it'd probably be even more galaxies.
Yeah, I think that the image will show us a point in the universe, a point in time in the universe before galaxies were even formed. And what
I don't think
about
it's
you
How
gonna
guys?
look
far?
that far. That's pretty far.
Yeah, that's pretty
Maybe
far.
So,
though.
Yeah, you
when was the first galaxy formed, anyways?
I wonder if they're gonna try to colorize it because with all the images they released so far, they like, since it's in infrared, they basically did like a brightness, they did really it's a black and white brightness map, but they just applied the color orange to it. So I wonder if they're gonna keep doing that for the rest of the JWST images, or maybe they'll try to colorize it based on like the spectra of the images they find. If they find like if they have the spectrum of hydrogen, maybe they'll color it like red or
Mm-hmm.
something, or who knows.
yeah, yeah.
So the universe is 13.77 billion years old, close to around 13.88, and apparently the first like galaxies formed a billion years after the Big Bang.
Yeah,
So we'd have to look back farther than 12.8 billion years, billion
yeah,
light years,
yeah. We'll have to
which
look back.
is a lot.
Yeah, it's a lot. It's a lot. I think one of the purpose of the James Webb Telescope, if I recall correctly, was to see past this huge cloud of ionizing particles, because at some point in the universe, it was so hot.
Apparently, it can see back 13.6 billion years ago. That's
Exactly.
insane.
Oh wow.
See? So we'll see. I think we will see before the formation of galaxies. Yeah. And it's meant, like I said, it's meant to see through that big cloud of ionized particles.
We'll,
Because
we'll we'll probably see some stars though, because apparently there was some stars 100 million years before that, the Big Bang.
okay, okay. So probably we'll see some stars, maybe some humongous black holes. We don't know.
And maybe some like small galaxies, well, just like collections of stars in a cloud of like gas, and it.
Yeah, I think it won't be small galaxies. I think it will be huge galaxies if we see galaxies. Because basically you have to think that since the beginning, since the Big Bang, basically the universe is expanding, right? And all the matter that is now somewhere in the universe was concentrated in a very small universe back then. So it was basically,
Relatively.
yeah,
Also,
yeah, relatively, yeah, obviously.
all this galaxy formed 400 million years after the Big Bang, and that's all we. Well, that's the oldest one we found. So
Yeah.
maybe JWST will be able to show us if there was galaxies only
Mhm.
like 100 million years or 200 million years after the Big Bang,
Yeah, yeah.
because we can't see back that far, so we don't know.
Exactly. We don't know, but I still don't recall when was the but yeah, like I said, the universe was very small. It was a soup of ionized particle, um, and that made it so that it's impossible to see beyond that soup of ionized particle. Um, but maybe inside of that, there's still there was a few galaxies or black holes or other celestial objects that we know very little or nothing about. So yeah, I think it will be very interesting, very very interesting. I'm stoked for these guys.
Currently looking to see how big the universe was 400 million years after the Big Bang. So.
So you said it can look back 13.6 billion years
So
from now, right?
only
So
0.11 billion years young, like before
so basically
or after this
a
universe.
hundred and couple million years after the Big Bang. That's amazing.
That's
Wow.
crazy. Yeah.
And there will be other uses also for the Webb telescope, um, such as studying other planets' atmospheres in conjuncture with the TESS satellite is doing. Um, so TESS is a satellite that is examining with this transitioning method. So it's looking at the wobble in stars to see uh, if there's planets orbiting them. Um, and so James Webb Space Telescope would be able to zoom in on the planet and look at the composition of the atmosphere. So that will be very interesting. Okay, and next mission is an ESA mission. It's the Bepi Colombo mission.
So just like 100 million years after the Big Bang, the universe would be small relatively, but it'd still be quite big
Yeah,
compared
obviously.
on a
Yeah.
human scale.
Yeah, on a human scale, yeah, it would still be extremely huge. Um, yeah, so Bepi Colombo mission. It's a mission to fly by around Mercury. And it's so the second of 6 flybys of Mercury was completed last month, and the third one will happen around the same time next year before the spacecraft arrives in Mercury orbit in 2025. And lucky for us, a couple images were taken during the flyby. Okay. and they show it to us in this article. So yeah, we can see a little bit of Mercury here. Um, does it give us? Okay, that's good. But doesn't allow us to see the next images. Okay, here we can see. Oh, that's a better one, I think. So that's an image that was taken in 23rd of June, and we can see a bunch of craters. Um, Mercury does look barren. Obviously, the pictures are in black and white, but yeah. So I don't know if you guys followed the what was it? The mission that went to Pluto. The was it Event
New
Horizon?
Horizons?
New
It was New
Horizons, yeah.
Horizons.
New Horizons? Yeah, New Horizon mission. And I recall it was pretty amazing when people saw the first images of Pluto. And it was very interesting how it seemed to have geological activity, right? Um, so do you think we will find something maybe as interesting with the flybys of the Bepi-Colombo mission on Mercury?
I don't personally think so, because since Mercury is a lot closer to us, we've been able to observe it from our from our ground-based telescopes, and studied a lot. Well,
Yeah.
Pluto is in the Kuiper Belt, so it's like we have to send a mission to get any form of high quality image.
So we've had Mariner 10 and Messenger already go to Mercury, so it's not like this is the first satellite that's going to Mercury. Even though like it's probably the most advanced one, but I don't think. I mean, we'll probably always find something new, but I don't know if it'll be anything like groundbreaking that'll change that'll change our like perception of Mercury, or who knows. But it'll be interesting, whatever it is. I just don't think it'll be like a like absolutely mind shattering Mercury discovery.
Scientists discover life on Mercury.
Yeah, that would be surprise. That would be very surprising. Life on Mercury. I mean, that's maybe the last place in the solar system that I would expect life on.
Besides Venus.
Yeah, apart from now Venus, maybe in the atmosphere with the last.
Yeah, in the
Yeah, maybe.
clouds.
Yeah.
Yeah, with the study that was published last year, I think, where there was I don't know, it was a particle guess.
Phosphine, right?
Yeah, phosphine, right? Yeah, that was linked to nothing that could be part of Venus, and so they said, well, we don't know what it could be linked to, so maybe it's life. But that article was rebuked by a bunch of scientists right after, if I recall correctly. I
Cool.
think two teams rebuked that article, so still, it could be. I think there's still it's still more probable to find life on Venus than on Mercury.
I mean, Mercury does have ice caps, so it's not that crazy, but probably
It does. Who
probably
knows?
next. Yes, it does.
Yeah, there are
Cool.
places on Mercury that are frozen cold because they're never exposed to the sun.
Oh, is Mercury tidally locked? I thought it just had like a long, uh, like a rotation period.
That's a good question. I don't know if it's tidally locked. Um, but yeah, to answer your question, the mission period, like I said, it's 4 years, I think. So it will arrive in orbit in 2025, or maybe it's going beyond 2025 for a while to take more pictures. And I think it's going to the sun after, if I'm not mistaken.
I looked it up. Mercury is not tidally locked. And
Okay.
then, well, actually, there's something that says it's not, and there's something that says it is, and there's something that says not.
It looks
So I
like
don't know.
for every 2 orbits of the sun, it rotates 3 times. So it's not like exactly tightly locked, but it's just a very slow rotation period.
Oh,
Mhm.
yeah, right.
But how fast does it orbit the sun? I remember it's been a while since I had to research this.
Yeah,
It's
it
in like
says here
83 days.
87.9 days.
So it rotates on its axis once every 29 days, so roughly a month.
Yep.
Yeah, it's interesting.
So
It's not a.
isn't that pretty close to our moon's rotation cycle? Well, I know our moon's
It,
totally locked, but like it
second.
still has days and nights.
Try to figure this out live. uh, if it rotates every 3 times, okay, so it'd be like 9. No, the rotation period would be 1 second. Oh yeah, so it'd be 180 divided by 3, because the rotation it rotates 3 times every 2 years, 2 Mercury years.
Oh, okay. I thought it was 131 Mercury year. Okay, so every
It's like 60.
58.6 days.
Yeah, that should be it.
Okay. Well, that's interesting. I myself have a particular interest in Mercury because it's a very carbonic planet, right? There's a lot of carbon on that planet, and when there's carbon, that carbon is squeezed hard enough. You guys know what we can find?
Diamonds?
Diamonds, yeah. So who knows? Maybe Mercury's core is just a huge diamond. That would be awesome.
That would
Well,
ruin the diamond economy, which would be very funny.
I think, well, like all those like super far future concepts of like Dyson swarms and stuff. Everyone talks about just like mining Mercury or like
Mhm.
basically like disselling Mercury because of all the resources, and it's not really a useful planet other than its resources. So
Yeah, Kurt's Gazette made a
yeah.
video on it.
Oh yeah.
Oh yeah.
It's theoretically possible, but would it break something in the solar system?
Yeah, exactly.
Like if you're mining that much amount of stuff, something could go wrong.
Yeah, it's about displacing matter, right? Around.
Like would we mine Mercury all the way to its core? Because that would be insane. That would change its orbital period, and
Yeah.
if we built a Dyson sphere on the sun, its solar output would slightly change, and a bunch of crazy stuff would happen.
Yeah, if you use like a mass driver, it depends on how fast you're going. But if you you could probably significantly change this orbit if you're mass driving like half of Mercury's mass off the surface.
Mm-hmm. But a Dyson swarm would give us a crazy amount of energy.
Yeah, we're far from being there yet, though.
Mm-hmm.
Yeah.
Very far.
Like we're talking about fusion being the future.
Yeah,
But
exactly.
fusion's probably closer. Fusion's probably closer than a Dyson sphere, but Dyson
But
swarm.
definitely, yeah. Like by the time we have a Dyson sphere, like people could just like have fusion like in their garage like easily like the technology will be like just like child's play at that point.
Yeah,
Like,
just a
Powering a house by doing electrolysis on water, then throwing it into your backyard fusion reactor.
yeah, basically, like you can go to Home Depot and get a fusion reactor or something.
That would be hilarious.
Yeah, our phone is now fusion powered, and it lasts for 1,000 years. The battery lasts for 1,000 years. That would be amazing.
Yeah, it seems a little excessive though. So your phone battery lasts for multiple times your lifespan.
Yeah, I know, of course, but still, I don't know. Maybe now the phones get passed on to the next generation, to your own children.
I don't. Could you
Yeah,
put a
maybe.
fusion reactor in a phone though? Like, can you compact that down enough to the size of a lithium-ion battery?
I mean, honestly, at this point, once you're making a Dyson sphere around the sun, I imagine that almost anything is possible.
Once you're making a Dyson sphere around the sun, you're probably once you have a Dyson sphere around the sun, you can literally just beam electricity down to phones.
Oh yeah, exactly.
No battery required.
No battery required. Yeah, we just microwave the Earth with the sun's energy and everything's fine.
Yep.
Yeah, I doubt anything of that is possible. But anyway,
Although, of
we
course,
want.
the second we started building a Dyson sphere, people who work in the coal and oil and natural gas industries are going to be like, NASA's ruining our lives!
Yeah,
They're so
Maybe
exactly.
mean.
Yeah.
any coal or oil industries. That's time we start building a Dyson sphere.
Yeah.
They,
Lucky for us, we won't be there to see it anyway.
maybe our AI versions of ourselves will be around to witness it.
Our AI versions of ourselves. So you're saying
Back up your brain to the cloud.
yeah. So like what was it exactly? It was Altered Carbon series. If I recall correctly, that suggested that concept. Yeah. All right. So before we derailed any further, I suggest we go back to our news, guys. And the next one I have for you is, like I mentioned it before, it's a JAXA Hayabusa 2 mission. Um, and the JAXA Hayabusa 2 mission is a return sample mission from an asteroid called the Ryugu asteroid, if I pronounce that correctly. So the Ryugu Sample Research Announcement of Opportunity Committee, so it's a group of people, analyzed submissions. So they selected 40 out of the 7 submissions that they received from 9 countries. And the full list can be found in a link that I will get to you guys. Just give me a moment. Right here. So the full list can be found here if you want to check that out. But yeah, basically, so it's equivalent. It's the equivalent of the Mars sample return mission that we discussed earlier, but now it's for an asteroid. And JAXA is even more advanced now with the asteroid return mission than NASA is with Perseverance. And by the way, if I recall correctly, NASA and the ESA, the European Space Agency, and JAXA are partnering on that Mars sample return mission with NASA. So thank God they're there, because otherwise I don't think any other countries have the space capabilities to do this. Yeah, so there's a little description here of the timeline that was that was announced. And yeah, so in December 2020, the Hayabusa 2 sample capsule returned to Earth. So it's already here on Earth and it's ready to be analyzed. So tell me, guys, what would you like to look at on these sample? It's the same question that I asked you guys for the Perseverance topic. Vincent?
Uh, well, I think it'd be pretty similar to Mars. I think, but I think we probably less focused on life. Like we probably want to find some of those like amino acid building blocks. But I think we more focused on well that's not that fair because like we're still trying to find out like exactly where life came from, right? I think uh the current leading theory or like one of them is that basically this bunch of asteroids brought all the building blocks and then they all kind of mix together on Earth, right? So I think we still want to like actually discover like all the building blocks on the asteroids, and I think that'd be pretty interesting because I think it'd be less focused on mining because that's still kind of far off relative to like actually doing the science of like finding life. Actually, I don't know how far off it is, but like, and we also like we know where the resources are in the asteroid belt already. So I think we'd be more focused on finding the building blocks of life uh than the actual like minerals and stuff in the asteroid itself. Even though it would be interesting.
Yeah, yeah, of course. And what about you, Will?
Um, Sorry, I wasn't really paying attention. I was just doing
It's
random
fine.
research on
Yeah.
amateur rockets because, it's interesting.
Yeah, of course it is. Yeah, and
Um,
it's the right place anyway. So I think one of the
yep,
purpose
but
of this mission is to explore the origins of our solar system, right? Um, and how our solar system came to be. Uh, yeah, I think. So let's see what they say. So okay.
another really interesting way we're finding out the origins of solar systems in general is I'm
Mhm.
pretty sure we have a few telescopes aimed at solar systems actually forming. Like we can see the planetary rings slowly congealing into planets. It's kind of insane that we can see it happening in real time.
Yeah, yeah, that's right. And I want to get back to the hypothesis that you mentioned, Vincent, of basically it's called panspermia, right? Where there's comets and asteroids that smashed into Earth's protoplanet like billions years ago, and allowed for life to develop because these asteroids and comets had the building blocks of life inside of them. So one of my hypotheses is how these comets and asteroids came to have these building blocks of life. So I don't actually think that the building blocks of life um, can be made with any process in these asteroid of comets. I think more that these could be found in protoplanets in the early solar system. And when these protoplanets smashed together, because these protoplanets had tectonic activities on them that would be more suitable, in my opinion, for the development of life. And so when these protoplanets smashed together and expelled millions of debris and pieces into space, I think that's how we came to have rocks in our solar systems that have building blocks of life in them. And then yes, we get to have panspermia where these smash into planets, and then maybe life goes from one protoplanet to another that way. I think that's a plausible hypothesis.
That is a one theory about how life got on Earth. It, like formed on Mars and then asteroid hit Mars and rocks flew with some bacteria hitching a ride.
Yeah, exactly, exactly. That's pretty much it. Yeah.
Or the other way around, like maybe we're all Martians, or maybe there's some life on Earth. It's actually just Earth people
Yep.
or Earth life.
Yeah.
So it'll either be so if we go on Mars, you might just find something that's really similar to
Oh yeah.
our own
Yeah.
bacteria. It might not like break any of the rules that we rules in air quotes that we found on Earth.
Yeah, it would be very interesting indeed if we find evidence of life on Mars, and it's so similar to Earth that we have a hard time distinguishing if we brought us we brought it
Mm-hmm.
with us over there, or if with
If it's contamination or if
yeah,
it's
exactly.
actually Mars life.
Yeah, exactly. That would be very interesting. All right. So there's about 10 minutes left to the stream. I still have a couple of articles to share with you guys, but what I will do is I will just do them in a sprint and get to the last one, and then give Will a little time for his own segment. All right. So um, one that I had was about a Chinese startup, uh, which is called Deep Blue Aerospace, and there was a video posted on Reddit of a grasshopper jump. So yeah, I wanted to check that out with you guys, but you can obviously check this out on your own. There was also a delay that was for Ariane 6. So Ariane 6 had a delay, and it's now planned to not fly until sometimes in 2023. So yeah, it was originally due to launch before the end of 2020, but there was an issue with the cryogenic connection system, and it required a lot of focus from the teams over there. But apparently the test was completed recently, so maybe there will be other issues, maybe there won't be. It's yet to be seen. And the last one I had for you guys was some news about Starship. So we always like Starship. It's our favorite ones, and that's why it's the last one that I always get to you guys. And I will display that one on screen. It's a tweet from Elon Musk, because apparently that's the only way SpaceX knows how to do public announcements. It's
The only
Oh
way
no, it's
Elon
not
knows to
from.
do public announcements.
Yeah, it's from SpaceX. Sorry, it's from the SpaceX Twitter. But apparently, that's how these companies make announcements now. It's through Twitter, just like President Trump used to do.
Mostly companies owned by Elon Musk.
Yeah, yeah, exactly. But yeah, 33 Raptor engines installed now on the Booster 6 on the ship. So good progress for them. Good progress. Yeah. So there's 5 minutes left. Well, just like you asked me, like I said,
Yep.
I planned for 10 minutes and there's 5 minutes left.
Just
So,
as you said, yep.
yeah.
So
Yeah, go ahead.
there's a really interesting new device by the Raspberry Pi Foundation. Most of you, it's not technically space related. That's why we saved it for last. But so most of you probably know that the Pi Pico exists. Well, they just released a wireless version called the Pi Pico W for $6 instead of $4, and so this will make IoT development much less expensive for just everyone. And yeah, should like rapidly create a new market for like hobbyist IoT devices. Like a bunch of new hobbyist stuff. It allows for people to develop stuff. Probably be used in some space project sometime soon. Maybe it'll go to the ISS like its big brother, the Pi 3 and 4 have.
Yeah, it seems very interesting. Do you have any take on that, Vincent? Oh, seems like. Oh, Vincent, you there? I think we lost him. What happens?
Probably.
Sorry,
So yeah,
I had
I'm excited to see
I
what
had
people.
my mic muted. Sorry about that.
Oh, yeah, okay, yeah, that happens. Yeah,
Yeah,
go
but
ahead.
basically, I was saying like this is like a 32-bit system that's like basically on an Arduino chip. If I understand, that's like super cool.
It's based on the RP2040 chip, which is the same used in the Pico.
Oh wait, the Pico is that also like a like can that run like Raspbian OS?
No, it's a microcontroller.
Oh, okay. Well, yeah, but this is still really cool though, because $6 is like super cheap, and yeah, it's pretty powerful. So yeah, this should be pretty cool for hobbies. Also, it'll help with during chip storage to give more people more options for microcontrollers.
Pico launched last year, and they just released the wireless version. So that's what we're talking about. I'm
Oh,
super
okay, yeah, I
excited.
understand now. Yeah.
I'm super excited to see what people do with this because people have already done a bunch of really cool stuff with the Pico. People have already added Wi-Fi, hosted web servers on it, added cellular to it, added Bluetooth, and now there's native Wi-Fi. So it's going to be super cool to see what people do with this.
Yeah, it seems really interesting. Um, I myself doesn't know a lot about these things, but hearing from you guys, it got me really interested in this. Yeah, all right. Well, thank you a lot. This pretty much closes our State of the Game event. And thank you all for coming. Thank you, Will and Vincent, for joining me. It's always a pleasure having you guys with me. And you can come back anytime. Will, on the other end, I think you have to come back every
Yeah.
time. Yeah, I pretty much need your support for
Ah,
that.
gotta make
Yeah,
sure all the streaming
yeah,
setup is working.
yeah. Everything Will does is so appreciated for the stream.
Hmm.
I don't think I will be able to do it alone. Uh, yeah, so thanks again. And thank you, Vincent, for participating in the discussions. It's really appreciated.
Yep, it was fun.
Thanks. Yeah, come back again anytime. And thank you to our viewers and listeners from everywhere. People in chat who asking questions.
Before we end the stream, do you want to show the Space Race merch?
The Space Race merch. I don't think I have any scenes with the
Uh,
Space Race merch. Oh
like,
yeah,
go to the website.
go to the website. All right. Yeah, I can do that.
Yeah, let's show our merch. Let's go.
Yep.
Yeah, sure. That's a really good idea. So, could you
And
talk about
it's
the
kind of
merch?
sad that we can't say something as simple as shop. Sorry, we can't say like ltgstore.com. We can only say shop.etsystore.org. It's a little bit more of a mouthful.
Yeah. Yeah, so there's merch now that is available for Nexus Aurora. You can go and check it out. There's even merch, I think, for the Space Race project.
Hmm.
So I guess it's shop all, and you
You can
can.
click on collections and then click on Space Race.
Oh, thanks. Yeah. All right, so there it is. So there's a Space Race sticker, Space Race cap. So you can look at these. And since we talked about the
I personally bought one of the hoodies, and they're so soft.
oh
It's
yeah,
kind of crazy.
yeah,
Like
cool.
they're so comfortable.
Yeah, and here's for Vincent. Here's the merchandise for MDR's SSAM
You clicked
mission.
on the Space Race collection.
Yeah, yeah, I did, but now I'm on the MDR's SSAM, I think.
Hmm.
Yeah.
Well,
Yeah. So this is
yeah, there's MBRS.
for you guys. So you can go and check it out. And thanks again for joining. I don't know if I switch the scenes. Will you see?
Don't worry, by the way, all of the profits from the shop goes directly back to supporting our projects. If you buy from the Sam collection, that'll go directly back to the Sam team for all project development.
Yeah, and same for the space race. Thanks a lot for specifying that, Will.
Hmm.
All right. And you can check out our socials here. Okay, and thank you guys for joining us today.
Thanks for watching.
Thanks for watching.